Okay, like this? Okay. I'll try it out. That's good. Okay, also I haven't asked for how long I should speak, but my plane is at 8:30, so I should stop before that.
Well, at some point we can have a break.
Okay, good. Yeah. Have more like a second hour. Thank you very much for coming. It's wonderful to be here in Vietnam. This is my first visit to Vietnam, and so also my first visit to Hanoi. And for this public lecture, my idea was to tell you about this project I'm doing right now, which is writing a new book about images and stories from mathematics. And the title I wanted to have was The Girl Who Couldn't Do Her Math, but in the end the publisher didn't like it, so this will not be the title, but it will be a book about images and stories from mathematics. And the idea is that I chose 24 images or pairs of images where each of them, of course, has a story and tells a story. And in very different senses, this is images from mathematics. Some of them are pieces of art, and some of them were just drawn by mathematicians, and some of them are photos of mathematicians, and so you will see. So what I brought you for today is a selection of roughly 10 of these 24 images, and I want to show you a bit what's the story behind that. And the reason why I'm working with images is because I believe, well, on the one hand, I'm a geometer, so I understand things from images, and for me, understanding mathematics in some sense is composing images and understanding images. But the other reason is that images transport things, and besides being interested in mathematics, I'm also interested in about how we view mathematics, how we make mathematics accessible, and that also means how to make mathematics attractive. So that's all part of the story. And so if I work on the perception of mathematics and the images of mathematics, then you start to think about what's your favorite images of mathematics. And when I talked to my publisher about that, then they said, of course, fractals. And in the end, there will be a fractal somewhere in a little corner of the book. But everybody has seen fractals, and so I thought that's not what's most important. Before I start with the book project, I still want to show you one of the records of music that we're playing while I'm working on this book. And it's this record. It's an album by Emerson, Lake and Palmer from the 1970s, and it's called Pictures at an Exhibition. And so if you want, what we're doing here is we are looking at an exhibition about mathematics, and so we will slowly look at what images we should really fill in. And even if you look at this closely, then you find that there's things like the old castle and the sage, which is the wise man, and you could still think of who should actually, what should actually appear in these empty picture frames. And on this rock album, there were empty picture frames on the front of the album, at least in one version of the cover. If you go to the internet, you find that there's a different version of this cover also, or if you buy the record, it's a wonderful record, rather strange. then you also find that there's a version with images filled in. Okay. There's seats here, just welcome. And there's even better seats over there if you want to see. Okay, ready to start? So if you have this collection of images, you have to sort them somehow. And what I will do is I will just work historically. So the oldest image will come first, and that's actually this image. So this looks huge here, but actually this is 4 photos of the same object, which is known as the Ishango bone. Who has heard of the Ishango bone? Okay, so it looks huge here, but it's a little bone. It's 10 centimeters long. So it's a tiny bone, which was found at the shores of the Ishango Lake, which is in the center of Africa. So I think the equator is somewhere here, and this is in the north of Kenya. It's this lake of Ishango, the Edward Lake, and on the north side of the lake there's this little place known as Ishango, where in the 1950s this Belgian archaeologist named Jean de Heinzelin did excavations in a prehistoric village which was covered by a volcano eruption, and that's where he found this little bone. Actually, this shows Jean de Heinzelin, this Belgian archaeologist, at Edward Lake. And in the back of the picture, you can see these high shores of where Ishango is. So the lake had more water in prehistoric times. So up there on the cliffs was active water, and that's where this little settlement was. And Heinzelin found lots of different things there, bones and tools and harpoon tips and whatever, and a lot of stuff. And he also found 2 little bones which had markings on them. And this is the drawing by Jean de Heinzelin from his original report about the excavation, which shows on this bone the markings. So he counted them and he marked how they would look like. And what's interesting about it is that if you count the marks on this left row here, then you find 4 numbers if you count them, and the numbers are 11, 13, 17, 19 in this order. Right, so if you're a mathematician, of course you have to say, aha, prime numbers. But this bone is now dated to be 22,000 years old. This is a long time before people knew about how to write, and so it's quite improbable that they knew about prime numbers, because somehow you cannot figure out about prime numbers without multiplication, for example. And so probably this is not prime numbers. So there's various other theories around what this is. The markings are too regular to be just a coincidence. So one theory was that this is a lunar calendar of some sort. Another theory says that these people counted in multiples of 6 or 12, or in systems of 12 we are still familiar with. And so these numbers, 11, 13, 17, 19, is just the multiples of 6 plus minus 1. Another explanation. So we don't really know what this is, but this is in some sense the oldest piece of mathematics that we know of. And now, different people have different further theories about that, and they have different versions to speculate about that. And the women's version of that is to actually point out that, of course, this was done by a woman, because, and so the earliest mathematician we know of is a woman, because of course the men were out there hunting. And one of the claims is that this is a bone of a toe of a lion or so. So probably it was the men out there hunting who caught the lion, but it was the women who stayed home, counted the days and kept the household in order and all that. And in that sense, the woman who did the math here, she's the Ishanto girl. The man's version of the story, of course, goes into science fiction and says that this Ishando bone is in some sense probably the same bone as the one that you might know from the science fiction movie 2001, where this one pre-ape man finds out that you can use a bone to kill another man, and then he throws up this bone into space, and then there's what they call the 3 million year cut, which is perhaps more a 30,000 year cut, to a space transporter where the communication with space transporters and rockets and stuff is of course done with signals and coding theory, and the thing that you need to do that is actually a coding theory, and that always means prime numbers. So these markings on the Ishango bone are even needed after you go from prehistoric times into space. And that's sort of the man's version of what the bone is about. Of course, it's your choice. End of story number 1, as far as I know.
What are the other
what can go through them, and people have tried to explain them, it's not so clear. And my impression was that there's a lot of speculation, and if you look at it more carefully, you see that actually this row and that one, it's pretty clear what numbers are there. Actually, these add to 60. These also add to 60, these add to 48. That's all multiples of 12. But you know how to interpret these markings is not so clear. And some of the markings might be somewhat accidental. And I think this is open to over-interpretation of all sorts. And there's one guy called Alexander Marshall, a science journalist who was asked by NASA to write a book about the development of mankind from prehistoric to NASA. And he started these speculations, and he was not an expert, but he took a microscope and analyzed this and all kinds of theories. So there's lots of theories about it. I think there's, we will never really know. Something was counted there. I think that seems safe, and everything else is speculation. Okay, so now we make the first 21,000 year cut and go into the year 1495, where a Franciscan monk called Luca Pacioli in Italy, and that's him here in the center. He was a monk, but he was also a professor of theology and of mathematics at basically all the Italian universities at the time. Everybody who studies economics, at least in Europe, knows the name because he wrote the first textbook which contained a complete rendition of the double accounting method in bookkeeping, which we still use. And so this was his book called Soma, which probably is actually this book here. And you see here in this portrait that he's displayed with all the insignia of a mathematician. There's a dodecahedron here. There's a drawing from Euclid on this plate, and actually it says Euclid here. And there's this amazing polyhedron here on the upper left in this portrait. And so this is a polyhedron that occurs again and again. And actually also the image I brought to you here, sort of as image from mathematics, that's an image from his next book. So his next book was a book about the golden section, and it had an appendix of 60 plates drawn by his friend and pupil he was living together at the time, who he taught geometry to. And you know the name of the pupil, it was Leonardo da Vinci. So Leonardo da Vinci drew all these images of polyhedra, and so there's the non-starred version and the starred version. So this is 60 plates altogether, and this is the 38th of them, I guess. And it shows a polyhedron called the rhombic cube octahedron, which consists of triangles and of squares. And here there's a little pyramid built over each triangle and each square. So actually, that's the same polyhedron that you see up here. I brought you here, that's from the same painting. So you see how this works. There's this triangle, and you go across a square, there's the next triangle. So the shape is really like, you take the shape of a cube, and you cut off the vertices so you get triangles, and you shave off the edges in such a way that you get squares, and then from the faces there will still be squares left. It's a very beautiful polyhedron, and in this case actually also a rather remarkable painting of the polyhedron, which is so good that some mathematician has claimed that only Leonardo could have painted it. But Leonardo didn't know Pacioli at the time that the portrait of Pacioli was painted, so it's perhaps not so probable. This here is the same polyhedron in a computer graphics rendition from this year, and you can say yourselves which ones you like better. It's a question of taste. People have called this one ingenious, and people have called this one completely wrong. And there were people who say it's ingenious because it shows all these reflections so nicely. And there's other people who say this is not worth much because all the reflections are wrong. So there's a question of taste. I think actually it is beautiful, and you can look at it for a while, and it's beautiful despite certain mistakes in the reflections. In the painting, this hangs on a thin thread, so it seems to be a glass polyhedron, half filled with water, so it must be rather heavy, and it hangs on a thin thread, so you can be a bit worried. Anyway, so this is this picture. The reason why I find this interesting, and again, people have discussed that very recently, is this is again this drawing by Leonardo. And what's remarkable about that is Leonardo made a real mistake here. Because actually the pattern is always you have this triangle pyramid, and you walk across a square pyramid, and there's the next triangle pyramid. And if you go to the left, you see the same, but if you go down here, then at this point where there really should be a triangle pyramid, Leonardo has drawn a square pyramid. So this is actually wrong. So Leonardo made a mistake. Big scandal. He's a genius, but he made a mistake. If you read his biography, there's various of them around, and you listen to a person who studied Leonardo for decades, then they tell you actually Leonardo was not good at math. Actually, even in basic arithmetic, he made mistakes again and again. Even when age 60, he counted his notebooks, which contained all his discovery. He said there's these 10 black notebooks and the 6 green ones, and there's the 2 leather bound, and so on makes altogether 48. And if you do the addition, you see it was only 46. So Leonardo was didn't have much of a school education. He was clearly good in geometry, but even formal geometry he learned from Pacioli age 50 or something like that. And so it's no wonder that he also makes mistakes in geometry. He's nevertheless a genius, and making mistakes is part of being a genius, I guess. Actually, this would be the replacement for that. This is a wooden model now of the same polyhedron, computer drawn, and as it's computer drawn, the probability is higher that it doesn't contain any major mistakes. But there's no guarantee either. But here now it's from the same perspective and with basically the same light from the side. And here you see clearly that there's this pyramid over a triangle which only has these 3 rods going down, one in the center. So that's Leonardo's polyhedron corrected. But again, of course, this is more beautiful. Of course, we can be critical and we say, you know, how can you make this sort of mistakes? But on the other hand, this was before the time of computers. It's not clear what models they have. Of course, today people don't do this type of mistakes anymore, one should believe. So actually this is the logo of the Mathematical Association of America, the way it was used in the 1970s. It's an icosahedron. That's the polyhedron that the Greeks were most proud of. The elements of Euclid end with the construction of the regular icosahedron. So Euclid was proud of it. And this is now in the 1970s. And if you look a bit at this drawing of the icosahedron in the logo of the Mathematical Association of America, you find out it's completely wrong. It really shouldn't be. And when this was discovered, they did replace the logo and corrected it. And now this is what they use now as a logo. And I guess now it's correct. But so this problem with getting drawings wrong is not something only with Leonardo. It even happens in rather modern times. Let me point out one more thing. This polyhedron with the rhombo-cube octahedron is something that's still very popular, at least in Germany. They sell this as a star for Christmas with a light bulb inside. And you can see again it's exactly the same polyhedron with the squares and the 8 triangles, which they are produced in a little village called Herrnhut in Saxony in Germany. And they ship these for Christmas and whatever all over the world to places like Japan and probably also Vietnam. And this is the logo of the company who sells these stars. And again, my exercise for you would be to study this logo and to discuss whether you think that this is an appropriate representation of this star. So much for Leonardo's mistake. Now we go into the 20th century. Now here's a quiz for you. This is a book cover. And the question is, who's the lady on the cover? Now there's an obvious guess, I guess. Namely that this should be Emmy Noether, who is a famous German Jewish mathematician from the 20th century, called the mother of modern algebra. I also brought you a photo of Emmy Noether at the train station in Göttingen. So this is Emmy Noether. And if you compare the two ladies, then you might come to the conclusion that if the lady on the right is Emmy Noether, and we do know that there's not very many photos of Emmy around and not many good ones. But if that is eminota, then clearly this is not. And actually it's not. And as with many of these quiz questions, I don't know who that lady is, and probably no one knows. What we do know is where this photo comes from. This here seems pretty small, but actually it's a Kleinbild photo, so it's 5.4 centimeters wide. That's the photo. And if you can see the photo, it shows this lady and an Asian-looking man with a violin on his lap at the train station in Göttingen, I assume, so the location is correct. And so you can even read here, this is Speise, this is short for Speisewagen, so that's the dining car of the train. So this photo is from an album that Chow had, who I think was a student of Hilbert, a Chinese student who then returned to the US. Algebraic geometers have to know the Chow ring. But this is not Chow, who didn't play the violin and was older at the time. There was this theory that it's a Japanese student of Eminota's actually, who then died rather young, but also that student didn't play the violin as far as we know. So it's not quite clear who this is, but probably this was a photo of this guy. And this woman there is just accidental. And Chow, who had the photo, had this in an album of Eminota photographs, which then the widow of Chow, who had never met Eminota, sent to Oberwolfach for their picture gallery when they were collecting Eminota photographs, and that's where the publisher got. So my claim would be that this is the worst photo of Eminota we have, because it doesn't even show Eminota. The best photo of Eminota actually is this one here, according to Eminota. This is a photo that we know it shows her. It was taken by Helmut Hasse, the algebraist and number theorist, on the boat to Danzig for the meeting of the German Mathematical Society in 1930. And later, when Eminota was asked to send a photo to Chicago because they were collecting photos of mathematicians, she asked Hasse whether she could get the photo to make a print to send to Chicago, telling Hasse that this was the best photo of hers that was around. So she wanted to have the shipped photo, and so in that sense, this is the best photo of Eminota, the mother of modern algebra, taken on a boat on the way to Danzig. She later emigrated to the US, had to emigrate, and died much too young. But that's the woman giant of mathematics of the 20th century, if you want. So that's portrait of a lady. Completely different topic. Was ist was is German and says what is what. And what is what is a series of books that apparently originated in the United States, started in 1961. In 1963 they first published the mathematics volume there. And so recently in a bookshop in Berlin, I saw that this series still exists. I had this as a boy, and so I pulled this from the shelf, and there's volume number 12 on mathematics. And this is the cover of the book. And I think this is interesting because these covers of these books, they are supposed to be inviting, and they somehow are supposed to represent the subject that the book is about. So this is a rendition of mathematics. So it's an image that's supposed to collect what mathematics is about. So you recognize actually there's fractals, right? There's a die, I guess this is for probability. There's the icosahedron again in a drawing that's acceptable. There's the pyramids for ancient stuff. I guess there's a bit of physics. This is not lottery, because lottery in Germany is also played with numbers up to 48. So, but I guess it's prime numbers, if they didn't make a mistake. There's a bit of space travel, so that's what